Like discrepancies.
Was it already in when you walked in?
So when this records, where's it recording to?
Where did you hit?
It didn't give me a choice.
But you're signed in, so it'll go to your Zoom account.
Okay.
It's not, it's your meeting, not the class
Good,
meeting.
good.
Then it should go to your Zoom.
Okay. Thank you very much. Appreciate it.
Yeah, no problem. All right. Well, let's do.
Bye.
Okay. Is this what you're expecting?
Yeah, it's just whoever wants to come.
Oh, okay.
Yeah, I'm just checking the online to see if it's ever.
Oh, yes.
All right, guys.
Yeah, just.
Just those of you that were assigned to make sure I was recording, I am recording.
Oh, just to make sure. Manual means it's hidden until we release. So yeah, it should be good for the midterm. The final. Oh, that's so stupid.
What's your
Well, at least that
question?
makes it feel better.
Let's just go through that annotation.
It was just not.
You don't want to go over any of my stuff? You're good with my stuff?
Lovingly.
Hundreds on everything. I'm listening.
Oh,
See,
I'm not saying that.
It's just, if I'm looking at that point breakdown, I gotta take first priority.
You're smart, but I
Oh,
just want to
sure,
make
you
sure
yeah.
that nobody else has any burning questions,
Right,
or if you want to
yeah.
just jump into Dr. Basu's equation.
Oh, that's so funny.
Yeah. Because that
Bye, guys.
Good job.
Didn't fail. Yay.
I was stuck doing calculations.
When I was a student,
I got incredibly close.
equation, calculations, you either got 100 or you got a 0. Even if you only missed 1 point, a 0. Yeah, that's what I said too when they said that.
That's crazy.
You either were perfect or a 0. And when I was taking calculations, when dinosaurs were over here. Well, and you know why? Did they explain to you why? Well, that, and you're the only one that knows how to do this stuff. Everybody on the healthcare teams, when it comes to math, it's you. It's you. Most nurses do not want to touch any math problems. It's not all. I'm not going to overgeneralize, but okay. All right, so I should pull up Dr. Basu's equation sheet, right? All right, give me a minute here.
Yeah, me too. They keep, they know how to do it. They know how to do it. Every time they, you know, who's on the was it? I think you should get, I think you should get it. I now I just have to decide what I want to sit at home. Oh, interesting. Take a look. No, I think it's available, but that one has more likelihood to get a phone. Yeah, but then that's right. Interesting.
I'm gonna, okay, oops, I'm gonna share my screen.
No, I don't know how to do it.
That's peanut butter down to always
You just say peanut butter? Yeah. Oh, like you're sloshing it down, like you're thickening it up when you're.
Where did that thing go? Still won't do it, huh?
like the tea, the towel, mine.
Girl, true. This is literally what we're doing. Yeah, it's so great. You're the one. That was your cooking off. Yeah, you could imagine.
That corresponds with that's specific to IT.
Yeah, the CP really be throwing me off. Because you always say CP, but then there's not like CP. You know?
It's a day.
Why won't it show somebody that knows what they're doing with Zoom?
See. Watch the and it's like some like really tragic story. They learned this lesson.
Yeah.
Like the partner.
Ew, not gone. Like, I hate those videos.
Dude, I get sucked in. I get sucked in. I'll watch those for hours.
That's so fun. Only the girls like. They're like boys too. Oh my gosh, she's like, girls sit down. Just tell them to leave you alone. Like, tell them to go. You know what gets me more? The bad acting,
Every time.
little episode, whatever, on TikTok.
I ignore
Like,
We'll do it. All right. I think, you guys all have your equation sheet that says one compartment, open model, IV bolus. Okay. So what I'm gonna do is sorry, I don't know how to, I'm taking too much time futzing with the technology here. So we're gonna take this first section that says one compartment, open model, IV bolus. So these are IV boluses, okay? And I am gonna start with the first equation. That's got, oh brother, come on. That says CP, does this keep flipping? Equals CP0 e to the negative KT. All right. This, as I heard Morgan talking, I went through this with Morgan last week. This equation I call peanut butter. I've called peanut butter like for 20 years, you know, because this equation along with this equation which I call jelly, are the two equations you need to do almost all of pharmacokinetics. I hope you all know this well inside and out. Don't even have to think about it. Drug in over drug out gives you your CSS average. Yes? Everybody good with that? You all know what all those components are. You also know what determines all of those components. The only thing we determine there is this, right? Now, what about peanut butter? Peanut butter is a one compartment decay model for a linear removed drug. So it's, we give a drug, IV bolus, boom, give it, boom. We pretend that it's immediately where it needs to be. And that your body is one big bag of water that gets eliminated at a particular rate of K, right? So IV bolus, what's your concentration at time 0 if you give, let's say 100 milligram bolus here? What's your concentration going to be? It's going to be up here and it's your C max, isn't it? It's the maximum it's going to be because you've given the drug, boom, it's there. And now it's going to start from there on out, it's going to fall. In a straight line, if you plot your natural log concentration, it'll be a straight line, yeah? Won't be straight if you do your actual concentrations, but if you take the natural log of the concentrations, that line will be straight, and that line, that slope is your K, isn't it? Is everybody good with that? Yes? All right. CP is any concentration on this line. And when I write this equation, you know, annoyingly, everybody does it differently. I usually write CT because I like to remember that that's concentration anytime T along this line. P stands for plasma, I think. Right? But the CP, I think, stands for plasma concentration. I like to think of it as CT. There's lots of different equations where different things are here, but the idea is all the same, and don't get caught up in it. All right, don't get concerned and caught up in it. Why did it do that little thing, I wonder? How do I get rid of that thing? Where's my erase? Duplicate, copy, paste. I don't want to do any of that. I want to get rid of it. Oh, well, ignore it. Okay. And then this CP is concentration at time 0 here. So this is this concentration here, isn't it? And then this CT or CP, however we want to think about it, is some concentration after that. This E just takes care of the natural log situation. Don't get caught up in that either. K, you know, is the elimination rate constant. And what is T in this case? T is the time difference between your CP at time 0 and your concentration at whatever time T this is. This is going to be this concentration, yes? Oh, I'm sorry. No, you should say no, Dr. Earl, it's this concentration. This concentration has got to happen after this concentration. It's helpful to remember that the C0 has to happen first and the other concentration has to happen second. And there can be no drug added in here. It's just the decay. So if we're doing an oral drug, we want to make sure, because we don't know when the oral absorption stops, right? It starts increasing and then it starts decreasing, but oral absorption could still be happening. You can't use this equation for that part because drug could still be being added, especially if it's sustained release, right? If it's a short infusion, if you're giving it for a half hour, you can say a half hour, but then at that half hour, you know that C max, and then you don't, and you know no other drug is being added, so you can use it after that, can't you? Does everybody understand what I'm talking about when I'm floating things up in the air? So if we're giving a short infusion, we give that short infusion, and after that, we're not adding any drugs. So we can use this equation for this whole part of the curve, can't we? The other important thing to note is this CP0 does not have to be at time 0, which is a little confusing. It can be at any concentration along here as long as it happens before this concentration. So you might want to think of this as C1 and this is C2. This has to happen first and this has to happen second on this decay line. Are you okay with all this? This is all review. Good. The other thing that I like to tell people is to think of this as the fraction of drug that's remaining at time T. So if we start here at 100, at time T, we just need to multiply that 100 times the fraction that's remaining at that time T, right? So don't get excited about that E. E to the negative KT throws everybody into a frenzy because it's weird. It's just a fraction that's remaining at that time T. And T is always the difference in time between the 2 points that you're looking at. You got to be able to think about this inside and out, backward and forward. And to be honest with you, it's actually just a rearrangement of your K equation. You all know how to calculate K, right? This is actually a rearrangement of this equation. So this is K times T, isn't it? Isn't T just the difference in those two times? And then this just rearranges and takes care of the E there. It's just a rearrangement, a mathematical rearrangement. So don't get thrown by this equation. It's a very important one. It's peanut butter, baby. Really important. I'm spending a lot of time on it because it's the basis for everything else. Okay? So everybody's good with that. Now, the next thing he has here is, wait, I gotta erase. Erase, erase, erase. Where's the darn eraser? There it is. Actually, I should just erase the whole. Can I erase the whole thing? All right. So he has, I'm gonna go back to a pen. CP is equal to CP0 e to the negative KT. We're good with all that, right? And then he has that equals dose. So this is still equal to dose over volume. Okay. Dose over volume, if you're giving an IV bolus infusion, boom. What is that? Dose divided by volume. What are the units going to be? Dose is in, let's say, milligrams. Volume is in liters. It's going to be milligrams per liter. What is that? It's a concentration, right? And what concentration is it? It's a concentration at time zero, right? Because it's like injecting that dose into your beaker that's so many milliliters or so many liters, right? So that dose over volume is just your Cmax, your concentration at time zero, isn't it? It's the exact same thing as this, isn't it? Just another way of saying that. Is everybody okay with that? So that's why this is really the same equation. It's just giving a little more detail on this. Now, this is only if it's of IV bolus, right? All right. Now, all right. This next one, I don't know why this is here, but it is. Area under the curve is equal to bioavailable dose over clearance. If you remember, and this is at steady state, if you remember, CSS average, our jelly equation, is bioavailable dose rate over clearance, yes? And dose rate is the same thing as dose divided by tau. You may not have thought about it that way, but it's true, right? Is everybody good with that? So I hope you can see, and so CSS average is the same, is determined by area under the curve divided by tau. So these are really the same equations modified by this tau being in here. So we get, so when we do an area under the curve, if we take the average of that area under the curve, that's our CSS average. So they're really just measuring the same thing. They're both drug in over drug out. One is just over actual forever and ever. This is just in that within that area under the curve for that particular dose. Does that make sense to everybody? So that equation shouldn't be new to you. It's a riff on CSS. It's a riff on jelly, isn't it? Just a riff on jelly. And then he has that also area under the curve equal to dose over V times K. What's V times K? It's clearance. That's right. Because remember, K, I made you think of it this way. Why? Because that's how it's determined. K is determined by clearance and volume. But can we just bring this over here and say clearance is equal to V times K mathematically? Sure. Does that mean that clearance is determined by volume? Heck no. We know that's not true, right? Which is why we're going through all this stuff. I don't want you to think that volume determines clearance or that K, for goodness sakes, determines clearance. No. We know what determines what, but can we use this mathematical equation? Absolutely. So this is the same equation as this. It's just getting at clearance by using, it's easier to know volume in K than it is to measure clearance. Clearance is the amount of blood that can be cleared. I mean, that's hard to measure, right? So we can get clearance from volume and elimination rate constant, which is much easier to get sometimes. Does that make sense to everybody? So again, none of this should be really new news. All right. Before we go on to, all right, then he also has total body clearance is equal to renal clearance plus hepatic clearance plus eyeball clearance plus toenail clearance, right? All the different organs, which these aren't, I'm being silly, but obviously total body clearance is the sum of all the different organ clearances for each drug in each patient. Same thing with Ks. Can add up the different renal elimination rate constant, hepatic elimination. We never really use those, but at least not that I've ever used. Renal clearance is the drug in the urine over the area under the curve. I don't use that either, but it's there for you if you want. I'm not sure why it's there, but it's there. Now, the next equation I really want you to know. And I'm going to bring a couple of parts out of this. 1 minus e to the negative nk tau. Now this is a tau, not t, over 1 minus e to the negative k tau. What is this? What is this? Either what's its name or what does it do? It's called our multiple dosing function. To me, this, you need to really know this inside and out, and you need to understand this and what it does for you and what it doesn't do for you. It is called the multiple dosing function, sometimes abbreviated as MDF, which I think is an abbreviation for other stuff too, but in this case, multiple dosing function. What does it do? Morgan knows. What is it, Morgan?
In your words?
Sure.
It's a magic carpet.
It's a magic carpet ride. It's a magic carpet ride to another dose. So you can take first dose information and take a magic carpet ride to whatever dose you choose. And in this case, it's the nth dose. It's the nth dose. So if you want to take a magic carpet ride from the first dose to the third dose, what would you put in there? A 3. If you want to take a magic carpet ride from the first dose to through 375th dose, you would put in there a 375. Yeah, you got the idea. We wouldn't put a 1 in there. That would make no sense because you've got to have first dose information in order to take a magic carpet ride somewhere else. Okay. And it makes sense that it's tau, not t, because these are repeated doses. So you need to know how often it's given to see how much it will accumulate over those multiple doses. Okay. Everybody good with this? You need to know the multiple dosing function. You will absolutely have to know that. I know you've used it in your quizzes, so you know you need it. And this is just a function you multiply. So if you already know the Cmax and you want to know the Cmax on the third dose, you take the Cmax from the first dose and you multiply it times your multiple dosing function with 3 in here for your n, and you've got it. That's it. What if you need to know it 2 hours after the max? So here's your max, 2 hours after. I'm running out of room there. 2 hours after. Sorry, that should be there. 2 hours after. Can you see that even? Why is that still there? Erased on mine. Anyway, 2 hours there. Here's where you would say, I need to do my Cmax from here. I need to peanut butter it down. How many hours? 2 hours. So I would put 2 in here because you need to know this 2 hours later. So you can either figure out your Cmax and times multiple dosing function for the third dose, putting a 3 in here. And then you have to multiply it times this piece here to peanut butter it down, 2 hours. E to the negative K tau, because this would be your C max, right? So then to get 2 hours later, you'd multiply that times E to the negative K2 in this case. So you just need to know the pieces parts that you have to put together to solve the problem, right? Is this helping? All right, now, if you put numbers in this equation, I'm not going to do it right now, but you can if you want to. The larger this n gets, the bigger this gets, the more this becomes closer to 0. This whole thing goes to 0. Okay, and if the whole thing goes to 0, that makes this, doesn't it? 1 over 1 minus e to the negative k tau. And what is that now? That's now called your accumulation. Is that what you call it? Accumulation factor? You didn't learn a name for it? And what it does is it's a magic carpet ride to steady state. It's a magic carpet ride to steady state. So you use it the same way you use your multiple dosing function, but it takes you to steady state. This is a really important thing to know because let's say your patient's in the hospital, you give them 1 dose of the drug and you say, oh, I like these concentrations. But then you don't think, oh, they're not only going to take it once, we got to see what it's going to be at steady state, don't we? So you can take that first dose information, multiply it times your steady state function or accumulation factor, or whatever you want to call it, the 1 over 1 minus e to the negative k tau, that'll give you your magic carpet ride to steady state for whatever dose. So do you want to know your C max at steady state? You take your first C max, you multiply it times the accumulation factor, right? And then do you want to know C min after that? Well, you need to peanut butter it down till you get to the end of your dosing interval. So if you're giving a bolus dose, that's going to be tau, isn't it? The time between your maximum dose and your minimum dose is tau, isn't it? Am I going too fast? Does that make sense? So I'm getting off the equation sheet, but to me, these are the important things you should know. So now I want someone to look at the equation sheet here. I'm going to erase mine. I erase all. I want to erase all. Why won't it let me? Okay, I guess I'll clear the page. All right. This is the equation there. Oopsie. CP is equal to dose over volume times 1 minus e to the negative nk tau all over 1 minus e to the negative k tau times e to the negative kt. All right, let's talk about each. These are 3 different pieces parts of the equation. What does, if we just had this part, what does this represent? What is dose over volume for an IV bolus? That's C max, isn't it? Or concentration at time 0. Is everybody with me on that? And then what's this piece? That's our multiple dosing function, our magic carpet ride to the nth dose. So this will be C max at the nth dose. Those 2 multiplied together, yeah? And then what's this? So far we have C max at steady state, right? Now what's this? This is any time t after that, right? Because this is our peanut butter part of the equation. So if I asked you to figure out the concentration on the 3rd dose, 5 hours after administration of an IV bolus, how would you change this? Well, you're going to have to be given the dose and the volume, right? Or the C max on the first, maybe he'll give you the C max on that first dose. Then what would we put in here for N? Three. We'd have to be given the K, or maybe you're given the half-life. You know how to invert between half-life and K, right? Excuse me. And then the tau would be whatever the dosing interval is, right? Same thing here. You'd have to be given that though, right? And then e to the negative K, which we already have. These are all the same Ks. Now the times I know mess you up. This is a T, not a tau. T tau, T tau. This is not tau. Why? Because tau is needed because you're doing this multiple dosing function. You need to know how often that's happening, right? But this T is anytime T after whatever this mess is, right? So this is at any time T. So what's going to go in here for that? 5 hours after the IV bolus. This is going to be 5, right? And then you just plug and chug it. The hard part is setting up the equation. So if I told you you need to know the concentration on the third dose 5 hours after an IV bolus, well, you know that you have to figure out the first dose first. So the first dose, you need to know the Cmax on the first dose. Then you can do this part next where you peanut butter it down for 5 hours and then take it to the third dose. Obviously you can do it in whatever order. They're all multiplied, right? So whatever makes you happy. And he gave you all this. I wouldn't have. But I think all these equations are more confusing than helpful to many of you. So I would give you just that, our peanut butter equation, and I would give you the multiple dosing function, and I would give you the accumulation factor or the steady state factor, and probably not a lot else. Because you don't really need a lot else, do you? Other than when you get to oral. All right, for IV bolus, though, that's really all you need. Right? You good? Does this help? Yes, good. All right, let's move on then to the next section, which is IV infusion. You want me to keep going? I'm not boring you. Maybe I am boring some of you. I apologize for that, but IV bowl. Okay, so we know to go to a whiteboard. Okay, so I'm going to erase this again. All right, so now we're no longer giving an IV bolus. We're doing an infusion, okay? So at time 0, what's your concentration going to be here? Assuming we have no drug on board, we're starting here, aren't we? At time 0. And we're going to give it at a certain dose rate or infusion rate, which is sometimes abbreviated this way. They're the same, aren't they? They're both just dose rates, aren't they? Don't get thrown. So we're going to give this drug at a certain dose rate until we reach steady state, and that's going to be our CSS, isn't it? Notice I didn't say CSS average. Why did I not say CSS average? No averaging is needed because it's just at a constant infusion. There's no giving it and letting it wash out, giving it, letting it wash out. It's just going to be at CSS average. And we already know what that CSS is going to be, don't we? It's just, we don't have to worry about bioavailability if we're giving an IV. So it's just drug in, dose rate over drug out. Or if you want to use KO and V times K, same thing, isn't it? It's all the same thing. Isn't it? This is not mysterious. Again, I wouldn't have given it to you. I would have just given you, I wouldn't even give you this dose rate over clearance because hopefully you know your steady state equation is drug in over drug out by now. You okay, Lucas?
Yeah.
You have a question?
Not at all.
Okay, good. Now, so we know what the CSS is. What we don't, what if we want to know one of these times before we reach steady state? How do we figure that out? Well, here's another important, here's another thing I would give you that I want you to know. 1 minus e to the negative kt. This looks familiar, right? this is a couple of things. One, we know that e to the negative kt is the fraction remaining. So 1 minus is a fraction removed when we're on our decay. It's a fraction removed, yeah? If it's 1 minus the fraction remaining. It's also, the more important thing here is it's the fraction of steady state achieved. Did I spell achieved wrong? I think I did. At time t. So at any time t here, 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 what's the fraction of steady state I've achieved? And guess what? That's going to give you your concentration at any time t along here is going to be equal to your dose rate over clearance times 1 minus e to the negative kt. So this is the fraction of drug, or the fraction of steady state achieved at time t. So if you're at half steady state, this is going to be 0.5. So it'll be 0.5 of whatever your eventual steady state will be. So this is another pieces part that you need to put together to build your equation. This is for a constant infusion though, not for an IV bolus. All right. So if you're going to give a drug over half hour, you're given a half hour infusion, right? And let's say you're giving 300 milligrams per hour is your infusion rate. Or if I told you your dose was 150 milligrams, you would be able to figure out that if you're giving it over a half hour, you're giving 300 milligrams per hour, right? That's something you've got to be able to do. So you put in your dose rate, you put in your clearance, whether it's a given clearance or you have to figure it out with V and K. Maybe you're given half-life again, so you have to make that change as well. Then you would say 1 minus e to the negative k, and what would your t be here? If you're giving a half-hour infusion and you want to know the C max, I forgot that part. What you want to know this, you want to know what this point is at 1/2 hour, because maybe you're stopping your infusion there and then the drug is going to decay from there. What are you going to put in for your T to figure out your C max there? Anybody? 0.5. Very good. Half hour, 0.5, half an hour. It's not that bad, is it? It's kind of like a fun puzzle to figure out, right? Does that make sense to everybody? So let's look at this equation he gives you here, okay? I don't want you to think that any of this is hocus pocus and hard to, it's some sort of mystery, because I find students are like hunting around for the right equation, hunting on the equation page. No, I need to know the C max. It's a constant infusion or a short infusion. I know I have to do dose rate over clearance times the fraction of steady state you have at time t. That's going to give me my C max. And then I can peanut butter from there if I need to. All right, so let's look at this equation here that he gives you. Cp is equal to Ko over K times V times 1 minus e to the negative kt. So what is this? Can anybody tell me in English what, well, first of all, what's this? Everybody says what? C max. This is drug dose rate over clearance. What is it? This is CSS, isn't it? Because remember, we're giving an infusion this time. Don't get tripped up. Because what is C max? C max is dose. This is dose rate over clearance, and certainly dose over clearance doesn't give us, this is dose over volume gives you C max for an IV bolus. This gives you CSS for a constant infusion. Don't get mixed up with that. That's a big problem with a lot of folks. Figure out where you are. If it's a constant infusion, it's got to be a dose rate, not a dose. Even if you're giving a dose of 150 milligrams over a half hour, it's still a dose rate of 300 milligrams per hour that you're giving, yes? Is everybody with me on that? No, really, does everybody get that? Because that's going to be a place that you can trip up. If you're giving a constant infusion or a short infusion, anything but an IV bolus, it's got to be a dose rate. So it's got to be in milligrams per hour or in grams per hour or in per minute. It's got to be in amount per time, not amount. The only time you can use dose over volume is an IV bolus. Because boom, you're giving it. Boom. All right. Does everybody clear on that? Okay. So we've got CSS. And then this part does what? Tells us the fraction of steady state we've achieved at time t. So this concentration is the concentration after a concentration during a short infusion, isn't it? Or during an infusion. And in this case, it's probably a C max, because if you're stopping the infusion, then it might say T infusion there, right? That's the time of the infusion. It'll tell you the C max after a short infusion. Or maybe you don't want to know that. Maybe it's not the C max. Maybe it's just the concentration an hour in. You just want to know what it is. Am I confusing you with that? Okay, good. So it's the concentration at any time T after you've started a short infusion, after you start an infusion. And obviously, as this gets bigger, this is going to go to 0. So this whole thing, the fraction eventually will be 1 or 100% once you get to steady state, right? All right. So he's also got this one that says CPSS is equal to KO over K times V. That's just your steady state concentration if you give an infusion, a constant infusion. It's the same thing as dose rate over clearance, right? Drug in over drug out. Not hard. Just different letters, meaning the same thing. This has got to be in amount per time. And this is in clearance. So this is in volume per time. This has to be in volume per time together. This has to be an amount per time together, which will give you an amount per volume or a concentration, which is what we're going for, right? All right. Now, here's another one. I'm going to just write out this part. CP1, to say max. Yeah. Ugh. Why is this so annoying? Why am I not able to? CP1 max. No, not CP1. CP max E to the negative K times tau minus T of infusion. Right? What is that equal to? CP max, and this is the peanut butter part. So we're peanut buttering. So let's make a picture quick. Here's our CP max. Maybe it's a time 0, maybe it's not, doesn't matter. And it's going to be falling off here at a rate of K. What's tau minus, oh, say there is an infusion. So I got to redraw this. CP max. Tau is out here, right? And this is time of infusion. So what is CP max times E to the negative K tau minus T time of infusion? What is that? This is tau. From 0 to here is tau. If we subtract the infusion, it's the difference between the C max and the what? C min, right? So that's just the C min equation, isn't it? Again, I wouldn't have given this to you because I would have hoped that you could figure out the difference between these 2 points. If you have the C max and you need the C min, the time difference between this is tau minus the time of infusion, isn't it? So if you're giving it every 8 hours over a half hour, the time difference between the Cmax and the Cmin is not 8 hours, but 7.5 hours, isn't it? That's why I always draw a picture, because it's easy to forget this infusion time. Just know your time difference when you're peanut buttering has to be the time difference between the 2 points that you want to see on that decay line. Is this helping? Decoding these equations that are really just the same equations over and over again. Loading dose, I don't know that equation. I don't know. I guess he wants you to use that, so that's fine. I don't really know that much about that equation. Okay, now intermittent infusion. So now we know it's an intermittent infusion. So let's say we're giving 300 milligrams. No, let's say we're giving 150 milligrams with a 30-minute infusion. All right, and you want to know the Cmax on the third dose. How are you going to figure out the Cmax on the third dose? All right, so we're giving a half-hour infusion, right? And let's say we're giving it every 8 hours just for grins, right? And we want to know the Cmax on the third dose. Well, first thing we'd have to figure out is the Cmax on the first dose. How are we going to figure out the Cmax on the first dose? It's going to be dose rate, in this case, 300 milligrams per hour over V times K. I'm not giving you all that, but you guys can figure that out. Times the fraction of steady state. We have 1 minus E to the negative K. And what's our time here? Half hour. And that's going to give us our Cmax here, isn't it? It's going to give us this point here, isn't it? And if we want to know that on the second or third dose, what would we add? Multiple dosing function. Or if we wanted to know its steady state, we would use the accumulation function, right? And you can know the Cmax at any time, any of the doses afterwards. Just multiply those all together, right? And what if I wanted to know the third dose and I wanted to know 5 hours later? We could do our multiple dosing function to the third hour, and then we would peanut butter that down for 5 hours after the Cmax. Here we could just put 5 hours in here, couldn't we? If it's 5 hours after the end of infusion. If it's 5 hours after the drug is administered, we'd have to add that extra half. We'd have to subtract the half hour, right? Does everybody follow what I'm saying? So it's just a puzzle. So you see this, you see the equation he has, Cmax at the nth dose is equal to Cmax of the first dose times the multiple dosing function. You could have done that without that equation, I think, right? And then that last equation there in yellow is Cp equals Ko over K times V. What is that? That's CSS, right? That's our concentration at steady state times 1 minus E to the negative K time of infusion. That's our Cmax when we're giving a short infusion, right? Times E to the negative K minus T to the T minus time of infusion. That's at any time T after the beginning of the infusion. So you have to know, is it at the beginning of the infusion or at the end of the infusion, whether you keep in the time or not that's in the, is for the time of infusion. Just draw your picture and you should be okay. And then you could take that to the third dose if you wanted. You'd add the multiple dosing function, right? You can just add pieces parts. Are you good? And then the oral absorption is really just plug and chug, isn't it? Does anybody want to go over the oral absorption? I'm just looking at the next equations. I think that's pretty self-explanatory. You know, the model independent piece, that's just the trapezoidal rule that you already know how to do, written in a way that I think is harder than actually understanding the trapezoidal rule. That's my view of the world. It's not his. So, but it's the same equation, isn't it? And then down here is really when we get to it. There's the multiple dosing function. That's what you really need. The accumulation factor, magic carpet to steady state. That's what you really need. Area to the curve is just dose over clearance. We knew that already. If you're giving it orally, you have to add the bioavailability in there. Your average concentration at steady state is bioavailable dose rate over clearance. Up, we already knew that. This is just broken down in a different way, right? Bioavailable dose over tau is dose rate divided by V times K, which is clearance, yes? Same thing. It's just drug in over drug out, as he's written there. CPN max is just your first dose max multiplied times your multiple dosing function. Again, I think this is the second or third time he's had this equation on here, right? CPS, so if cover up that first thing and it says CP1 min times, oh, the accumulation factor. So that's going to take you to min magic carpet ride to any steady state or any to steady state. So that's going to be your C min at steady state, right? If you cover up the answer here, C max on your first dose times the accumulation factor. Oh, that's the maximum concentration at steady state. Yes. And then he's got the Michaelis-Menten, or not Michaelis-Menten, Henderson-Hasselbalch there for you, but I don't know, does he use that? I don't think so. Does that help? Go back and do some problems and see if you can put the equations together yourself. I would focus on accumulation factor, multiple dosing function, that fraction of steady state that you achieve, and make sure you know the peanut butter stuff, right? That e to the negative KT comes in very handy, doesn't it? Don't get tripped up too much about the T. The T is just the time difference between the two concentrations that you're talking about. It could be tau, it could not be tau. It could be tau minus T, time of infusion. It could not be that. But just if you draw a picture and you know what you've got and where you're going, you should be able to figure it out. Make sure you can only use the peanut butter when the drug is descending. So don't include like the up, it's only the down. Does that help? It's actually pretty fun. And not hard, not hard. I think what I teach is a lot harder. But that's just my view of the world, so. Good luck, you can do this. You can do hard things. Did he open up the homework? He said he was going to. All right. Practice some homework problems using this, way of this view of the world, and I'll bet you'll be in good shape. Thank you. Good luck. Did that help?
Yeah.
Good.
Do the portfolio, like the thing that's